will try to understand so how this program will be executed by your machine. Okay, so first one important point is this is not directly executed by your machine. Before that there is a compiler program. Okay, so how to understand that compiler program is that compiler program will have corresponding instructions for your high level instructions, let's say. Okay, so that means the logic part of your program plus something extra. Sir, why something extra? Whatever I wanted to do, then I wrote it, right? Then why something extra to be done? I will tell you. You said simply int x, correct? But you never said where to store that x. That means, so you never talk about the storage where the x variable should be stored. Similarly, when there is a x equal to factorial of 4, see this one. Because of that, suddenly being here, you have to go to factorial method and you have to execute all these things. On that also there are two local variables, one is x, one is y. Then your compiler has to take care of storage details of x comma y, where to store, and scope and lifetime of all these variables. And at the same time your compiler has to remember the control sequence. From 2 to it should come to 4, after that 5, 6, 7. Whenever return is executed, you have to go back to line number 3. All these things are remembered by compiler's extra code. So that's why some extra code is required. Now I am going to talk about such compilers extra code. What is that extra code, and what is the functionality of that extra code, we'll see. For that, what I do is I show you the main idea about that extra code. In that extra code, what happens is there will be one stack. That means your compiler maintains stack data structure, and how this stack will help your compiler to run this program very effectively, we'll see. First of all, you have a line number 1, correct? Then because of that, what happens? Because it is main program, then one activation record will be loaded. Remember this thing. Since the environment where your program's control exists is main, correct? Yes. Then there is a local variable x. Then automatically, because of this extra code, some memory will be allocated for your variable x. Then it will go to line number 2. Okay, then in line number 2 there is x equal to factorial of 4. You wrote it, correct? Because of that we have to assign the return value of factorial of 4. But before that we have to execute factorial of 4, correct? Then compiler's extra code will work such a way that what that extra code will do is it will create one more activation record on behalf of factorial of 4. Finally, I am showing you the memory management of your compiler because of this extra code. Okay, now we'll see what happens. So whenever factorial of 4 is called, then control comes to line number 4. Okay, now you tell me, once this method is done, where to go back? What is the return address? The return address of this factorial method is, you see here there is a return. Because of that we'll go to line number 2 back. Why? Because that return value to be stored in x, correct? For that we have to execute line number 2. That's why, so factorial of 4 also remembers line number 2. That means this is return address. So it's because of what? Again extra code. That's why I can say that now I'm explaining you that extra code, this extra code. Okay, now after that what to do? Just we started factorial of 4, then there is a local variable, then your compiler, because of that extra code, creates a local variable n. Okay, then n's value will be updated by 4 because of call. Then control comes to line number 4. Then see, now from now onwards your compiler is very happy because your compiler is maintaining environment of factorial. That's why happily your compiler can access whenever you write n. When you write n directly, it will refer this one. Okay, so what is that? N 4. Is it 0? No. Is it 1? No. Then control comes to line number 5. Execute it. Int x equal to n. Whenever it sees a definition, again one memory location will be allocated in this top of the stack. What is that? X. Now, so these are all called activation records. This is main activation record. Okay, activation record. This is one more activation record. In that way there will be lot of activation records. Now come to this line. but x equal to n. What is n value? 4, right? I am talking about line number 5. Local variable is created and it is initialized with n, which is 4. Next, int y. One more local variable will be created, y. Its value is what? Factorial of n minus 1. What is factorial of n minus 1? It's a function call. Whenever a function call is seen by your compiler, it will create one more activation record. This time what is it? Factorial of n minus 1. Being here, what is n? 4. 4 minus 1? 3. Correct? So factorial of 3 will be created. Now the same story. See, because of this factorial of 3, control goes where? To code the starting line of the factorial method. There is a local variable n. Then n will be created and n value updated by 3. Then this line will be executed. What is n now? Sir, will it refer 4 or 3? Simple. So current activation record is this one. In that, whatever the variable you see here, then that will be resolved by this activation record. Since n value is 3 now, then it will be executed by using n value of 3. Now you don't have any confusion, right? See, then you can understand that though you write one variable n, then multiple copies are created. That's the reason. Understand? Now 3 equal to 0, false. 3 equal to 1, false. Then we'll come to line number 5. In line number 5, there is a definition x, then x will be created. Let me do now quickly. You understand it. So x equal to n. What is n? 3. Then next, this line y. Y is what? Y equal to factorial of n minus 1. What is n? 3. 3 minus 1, 2. Since it is a function call, then we create a new activation record. Let's say that is factorial of 2. Now again same story. One local variable n will be created, right? And one more thing we have forgotten, that is return address. Here always we have to write the return address. This is return address. From factorial of 4 we have to go to line number 2. From factorial 3 we should go to line number 6. Remember it, okay? Now here also from factorial of 2 where we should go? Whenever you are executing factorial of 2, we were here. When you are here, then when you go out, you have to come back to this one to return the value. Then what is the line number? Line number 6. What are the local variables? One is x, one is y. What x is getting? N. What is n? N is 2, right? Here also, what y is getting? We don't know at this moment. Here, what is y getting? Y equal to factorial of n minus 1. Factorial of 1. We have to write factorial of 1. But factorial of 1 is not computed. Then we have to create new activation record. Okay, then in factorial of 1, when we go out because of factorial of 1, why are we going out? Because this is the starting point of factorial. Then that is what I am saying. Going out means we have to come here again. Then we have to execute all these things. Then we have to come back. Where to come back? See, simply you see this one. Because of this we go somewhere else and we come back, and we have to come back to line number 6. Let me maintain line number 6 here. Then what to do? So factorial of 1, n value 1. Execute this line. 1 equal to 0, false. 1 equal to 1, true. Then return. This is the first time we are encountering return, right? I will tell you what is the meaning of return. Whenever there is a return line which is written by you, your compiler has extra code. It will understand it as a close of that activation record, because we are going from this function. That's why, what is the function we are running? This one. This will be closed. And what is the return address? 6. Blindly your compiler will go to line number 6 and it executes it with return value. What is the return value? 1. Go to line number 6. Yes. And apply that return value 1. Then this instruction will become clear, y equal to 1. Because of that, your compiler will go to blindly variable y. Sir, which variable? This one or this one? This is already closed. Then this one. And it's perfectly right, correct? Because we have to return that to factorial of 2. Then here 1 will be stored. Understand? Now what is the next line after line number 6? Line number 7, obviously. Since it is written, again what happens? Same thing happens. Then one more function call will be closed. What is that? This one. Okay. So, but what we have to return? X star y. What is x star y here? 2 and 1. 2 star 1, 2. Remember, we have to return 2 to return address 6. Go to return address 6 and return 2 here, because this is function call. Then instruction will become y equal to 2. Blindly go and update y. Which y? It will be decided by your stack at top of the stack. Go to top of the stack. This time it is this one. then you write 2. You try to understand this one. Compiler is maintaining, strategic sequence, so that automatically, this recursion can be evaluated, correct? So that's why this recursion kind of things will be easily evaluated. Now where are we? So we reached to this factorial of 3 and we submitted the return address, right? I mean return value. What was that? 2. Then what to do? Line number 7. Return x star y. What is x star y? 3 star to 6. Since it is written, close it. Then return that 6 to line number 6. See, this is return address. Line number 6. Submit 6 to where? Y. What is y here? What is current activation record? This one. What is y here? This one. 6. Then go to line number 7. In line number 7, x star y. What is x? 4. What is y? 6. 4 into 6, 24, because of this instruction. Then 24, but it's returned. That means close this function, go to return address what? 2. Blindly go to line number 2 and replace that with, this 24, correct? Then x equal to 24. So blindly update that. What is the current activation record? This one. Update it. So that's why. Then x equal to 24. In that way, all your local variables will be maintained by your compiler in a stack. This is called stack of activation records. Each one is called activation record. You tell me now what stack contains? Stack contains return address. Second thing, all the environment of the method. Environment doesn't, it means that just local variables. Okay. Now, so where are we? So line number 2 is done. Then line number 3, print x. What is the top of the stack now? This one. In that, what is x? This one. So 24 will be printed. Though you have x in so many places, appropriate x will be taken because of this actual calling sequence or stack, correct? So now print x will print 24. This is the way your methods or programs will be executed by your compiler. Further, you remember your compiler maintains some extra code. So whatever the illustration, whatever I did, all that things because of this extra code. Okay.